Hello guys, my name is Balakrishna Srivastava and welcome to Code with PK. So in this video we write a Java code to create a game of 2048 on console/command line. A simple text based game of 2048 that we can play on command line or console, right? And what was game of 2048 if you remember? So this is the game. If you remember, we are going to code this. Okay. The target of this game is to get a 2048 tile. Okay. Alright. And initially we are going to make a text based console game, and then we are going to move on to GUI. We are going to write a GUI in both JavaFX and Java Swing. Alright. So when we are done with our version of the game, it will look something like this. Okay. So we have four moves: top, down, left and right, and we use WSAD, the standard gaming keys. If you have ever played computer games before, I guess I'm like hoping you have. Okay. So if I do up, okay, enter, right enter, right enter, up enter, right enter, right enter, up enter, right enter, right enter, right enter, up, left, up, right, down, up, up, left, right, right, up, right, uh, down, right, right, up, right, up, right. Okay. And this will continue as long as the game is not over. Okay, that there is a possible move or a place for a new tile, or you have won the game. Okay. All right. So we are going to code this game on Java. So before we begin, it is a request to please subscribe to my channel, because out of 100 viewers, only 3 or 4 are subscribed. More than 95% of my audience is not subscribed, and a subscription is very important. So please do subscribe to my channel. So let's begin. So the first thing that you have to do is show the board. Now how do we show the board? So let us think of the board as a 2D array of 4 by 4. Okay, we take a 2D array of 4 by 4. Okay, row 0, 1, 2, 3, column 0, 1, 2, 3. Okay, int array of 4 into 4. That's what we take to store our board. Okay, so location 0, okay, is going to depict an empty tile. So 0 is empty tile. Okay, and then we have tiles 2, 4, 8, 16, 32 and so on till 204. Okay, if you win the game, right? We have to show this grid, this 2D array on the board, right? So let's break this further. Okay, we know that output in Java happens from left to right and top to bottom. Okay, so if I want to print something like this, I will print this top line first. Okay, that is, I print something like this. Okay, the top line, then I print a row. Okay, so if row values are say 0 2 4 0, okay, 0 is blank. Okay, so I print 0, a pipe symbol, 2, a pipe symbol, 4, a pipe symbol. Okay, and you can also add a pipe symbol before the starting of the row. Alright, so we printed this top part and then we printed this row. So if we print this top bar again, okay, followed by another row, say it was 2 4 0 0, okay, including pipe symbols. Okay, then again for the third row, say columns were same 2 4 0 0, okay, including the pipe symbols. Okay, and for the final row again 8 8, say 4 4, including the pipe symbols. All right. Okay, so we printed the top bar, row, top bar, row, top bar, row. Okay, and then the final this. Okay, or you can print this separately. Okay, and print row plus bottom bar, this part. Okay, bottom separator. Okay, so you print top separator first, then row plus bottom separator, row plus bottom separator, row plus bottom separator, and row plus bottom separator, and you should get something like this. Okay, so that's what we are going to code. So going back to the code, okay, so finally I'm going to create an object of this class and call the play method to play the game. Okay, so this will contain all the methods and the data members that you will need to play this game. All right, so I'm going to start with a 2D array of int. So private int board of size 4 into 4. Okay, I create this board in the constructor of this class. I say board is new int 4 into 4. Okay, you can take a final variable public static final int size as 4. Okay, and then use size instead of 4 everywhere, but that's okay, that depends upon you, right? This is more helpful when you want to make the game scalable into larger sizes, right? That you use size instead of 4 everywhere. Let's get 4 into 4 done and we'll think about we can do something for variable size. Okay, so when you create a board, all locations of this 2D array is 0. Okay, and for us 0 is blank. Okay, let us now try to write a function to print this board public void show board. Okay, all right, what we discussed here was print the top separator first. So I'll say print the top separator. Okay, so I'm going to say for int I equal to 0, I less than 4, I plus plus. Okay, assuming each row, okay, this part, okay, this part I'm assuming say maybe 6 characters. Okay, and that happens into 4. Okay, for one column, another, third and fourth. Okay, so I say system dot out dot print, okay, 1 2 3 4 5 6. All right, and then change a line, sys out change line. Okay, then print each row. Okay, so again for int I equal to 0, I less than 4. Okay, to print each row, what we were doing, okay, we were printing this first pipe symbol. Okay, then the value at this location ij followed by sign symbol, value at location ij followed by pipe symbol, value at location ij followed by pipe symbol, value at location ij followed by pipe symbol. Okay, so I print the first pipe symbol first, print the first pipe symbol. So system.out.print pipe. Okay, and after this row is printed I will have to change a line. Okay, okay, so for each column int j equal to 0, j is less than 4, j plus plus. So first separator is printed, we then print value and separator again. So I say system dot out dot, I'll say use printf. Okay, I'll say space percent minus 3s space, okay, and I'll pass the value blank plus board of I comma j. Okay, followed by pipe symbol. Okay, and then finally when this is printed I change a line. Alright, and then print the bottom separator. Okay, that's what we discussed, print a row, print a bottom separator. Okay, so I say print the bottom separator. Okay, since we are already using I for the outer loop. Okay, alright, this should give us something. Let's see what we get. Okay, so I will add a main function, say public static void main string args. Okay, I create an object of this game of 2048. Okay, I say game of 20 console equal to new control v. Okay, I'll just call this show board method. Okay, compile, run. I get something like this, and this does not look pretty at all. Okay, so I get two pipe symbols. Okay, because why am I printing it here? Okay, clear, compile, run. Okay, so I get 4 into 4, but I need more spaces, so I maybe add one more dash and one more dash. Okay, clear, compile, run. Okay, so it is almost similar to what we saw in the sample run, but the width of each row is only one line. Okay, I want to make the width of each row equal to 3 lines. Okay, so a blank line before this is printed and a blank line after this is printed, and then this. What am I trying to say is, if I want to print say 2 4 8 and 0, okay, pipe symbol, pipe symbol, pipe symbol, pipe symbol. Okay, but before these separators, okay, after and before this row, okay, I want another blank line of, okay, right, so that I have white space here and white space here. Okay, so I go back, I say before, okay, print the blank space before the row, okay, then print the blank space after the row, okay. So blank space is going to be very similar to the row, okay, system.out.printf, this exact same thing, okay, and just a blank here, okay. So, and I change the line as well after this, okay, paste this, okay. Let's see what we get. To fix this, let me just change this to 1 2 3, okay, 1 2 3, okay, clear, compile, run. And I'm missing a pipe symbol here and here as well. So what we can do, instead of %-3s, 1 2 3, we don't need these arguments, okay, so you can simply do system.out.print, okay, system.out.print here as well, and a pipe symbol before each of these blank rows, okay. So clear, compile, run, okay. Pipe symbol, oh, pipe symbol was supposed to be here, pipe symbol here, okay, okay. So Java C, nice, okay. So this is what we want, something like this, okay. Next step is, I don't want zeros, okay, zeros are blank tiles, okay, I just want 2 4 8, okay, any non-zero value, okay. So I say if board of I comma j equal to 0, okay, I will print a blank, okay. Else, for non-blanks, for non-zeros basically, I print the integer, okay. So I'll clear, compile, and okay. Let's just set some random locations to non zero values, okay. So I'll say board of, say, 1 comma 1 is 4, and board of 2 comma 3 is 8, okay. So clear, compile, run, okay. All right. We can also do this using a method to add random 2 or random 4, because every time a turn is played, a random 2 or random 4 is added to the board, okay. So I'm going to write a method, okay, public void add random digit, okay, int digit, okay. I want to add a random digit which is going to be obviously 2 or 4. When I call this function, I'm going to pass 2/4, either 2 or 4. I have to add this digit randomly somewhere on the board, okay. So I need a random class object, so I'm going to say private random, okay, random, okay, input java.util.random on top. I'll say create a random object, okay. So random equal to new random, okay. All right. And okay, I add random digit on the board, okay. Now how do I do this? I generate a pair of I j, okay. I say int I is random dot next int, okay. Bound is going to be 4, so I get a random value between 0 to 3 inclusive, okay, which is going to be my row number, similarly my column number, okay. Now I have to make sure there is only zeros here, because 0 represents a blank tile, and there is not a non-zero value here. That is, generate I comma j as long as this location on the board is occupied, okay. While, okay, board of I j is not equal to 0, okay, you say I is generated again, okay, j is generated again, okay. And this loop stops when this condition is false. That is, we find a location where board of I comma j is 0, and we set the digit at this location, okay. So board of I comma j is my digit, okay. All right. So clear, compiles. Okay, let me add, instead of hard coding, I say add random 2 and random 4. 2, okay, add random digit 2, okay, add random digit 4, okay. All right, so it's compile again, run again, okay, run again, run again, run again, run again, run again, run again. So the board and adding random 2 random 4 works just fine. Okay, now let's move on to the gameplay. Okay, I am going to write a function for any text-based console game. There should be a play method that in short does everything game of the play should do. Okay, public void play. Okay, what this does is play the game. Okay, so for playing the game, what you do, set up the board. Okay, and in setting up the board is basically you add random 2 and random 4. Okay, so I do add random 2 and add random 4. Okay, add random 2. Okay, you can choose, okay, randomly to choose two twos, two fours, or a 2 and a 4. Okay, but that I don't want to go into too much detail, right? That is a trivial code. I just want to start with a 2 and a 4 somewhere on the board. Okay, all right. So when you are playing the game of 2048, it is not over until you get 2048 on a tile, or there are no more, there are no more moves possible. Okay, so while the game is not over. Okay, so I say while not is game over. Okay, now I will write this method is game over. Okay, so I'm going to say public boolean, okay, returns true or false, is game over. Okay, this returns true if the game is over, returns false if the game is not over. Now how can the game be over? Game is over if there is a 2048 tile on the board. Okay, so what you have to do is search the board for a 2048 tile. So I'm going to write another helper method, public boolean search on board int, say x. Okay, you have to search for this value x on the board. So what we do is we do this, we iterate each row and column. Okay, remove this, remove this. Okay, now if board of I comma j equal to x, I return true. Okay, else return false. Okay, so if I'll say, let me add another method, public boolean game 1. Okay, game is 1 if return search on board 2048 returns true. Okay, so game is over if game is 1. Okay, we return true. Okay, then game is not over if there is a blank tile on the board. So if search on board, okay, for location for digit 0, integer 0, if this is true, then the game is not over, we return false. Okay, so the game is over if 2048 tile is on the board. Okay, if this is not the case, we check if there is a blank tile on the board, it means if the game, that is, it means the game is not over. Okay, so if there is no 2048 tile on the board and there is no empty tile on the board, then the only way the game is not over is the user can make some left, right, up, down move where he can merge values. Okay, so finally game is not over if user can make a move. Okay, all right. So I write another method to check if on a filled board can user make a move. Public boolean user can make a move. Okay, now let me explain this. Okay, so what I'm trying to say is our board, okay, which is, okay, it is full, there all locations are full, say 2 4 8 32 64 2 2 4 8 16 32 4 8 6 16, sorry, not 6, sorry, 4 and 4. Okay, the board is full, but how do we know if there is a move possible? Okay, if there are two continuous like adjacent values that can be merged. So these two can be merged. Okay, these two can be merged, these two can be merged, and these two can be merged. Okay, so even if the board is full, no empty tile. Okay, that is no tile with value 0. Okay, because we are using a 2 into 2 integer array to store the tiles. Okay, and 0 indicates empty tile. Okay, so how do we know if two adjacent values can merge? That is if they are equal. Okay, any two adjacent values which are equal. Okay, and this is possible for all locations. That is if this is my board. Okay, and assuming it is all full. Okay, a move is possible if these two can merge, 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 these two can merge. And for column wise as well, these two can merge, these two can merge, these two can merge, these two can merge, these two, 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 and these two. Okay, all right. So how do we do this? So I am going to solve this problem or checking if the move is possible or not in three subparts. Okay, the first is basically, okay, checking for 3 into 3 board. Okay, and this is we are doing because we don't want index out of ones choose, right? So first I check for this board. Okay, so my I basically goes here, my j goes here. Okay, so if these two and these two, okay, these two, these two, these two, these two, these two, and these two can merge, user can make a move. Okay, so I go back to my code, I say for int I equal to 0, I less than 3, not 4. Okay, therefore int j equal to 0, j is less than 3, not 4, j plus plus. If two adjacent locations have equal value, return true because user can make a move. Okay, so if board of I comma j equal to board of I j plus 1, same row or same column as well. Okay, right, or board I is equal to I plus 1 j. Okay, in either of these cases I return true that a move is possible. Oh, this or is not needed. Okay, so this is my first part, check 3 into 3 board. Okay, and why am I doing this? Because if I take a 4 into 4 board, okay, so for a 4 into 4 board, when I take j plus 1, it goes out of bounds. When I take I plus 1, it goes out of bounds. Okay, so I'm considering this 3 into 3 first. Okay, then I consider this last row. Okay, this is going to my b part, 3 into 3 is the first part. Okay, and then I consider the last column, which is the c part. Okay, so check if two equal adjacent values in the last row. Okay, so in the last row I iterate columns from j equal to 0 to j is less than 3, j plus plus. If board of last row is going to be 3 of j equal to board of 3 and j plus 1, return true. Okay, so this part of code is checking for this, and this. Okay, j starts from 0, goes to less than 3, so j takes value 0, 1, 2. For 0 we check this, for 1 we check this, for 2 we check this. Okay, similarly we check if two equal adjacent values in the last column. Okay, so in the last column we have to iterate rows from 0 to less than 3. Okay, last column is j equal to 3. Okay, so board of I equal to I plus 1. Okay, on the third column, on the column with index 3. Okay, two adjacent values are equal, we return true, and this is checking this part. Okay, j is equal to 3, I is 0, 1, 2, 3. Okay, this, and this. Okay, all right, finally we return false. Okay, because no move is possible, so we have to return false. Okay, so this is a function that checks if a user can make a move. Okay, and finally game is not over. Okay, so I say return not user can make a move. Okay, So game is not over if user can make a move. So if user can make a move, return value is true. I do not, I return false. Okay, the game is not over. Okay, vice versa. If user cannot make a move, okay, return value from user can make move is false. Not or false is true. It means the game is over. Okay, so I have completed my is game over method. Okay, right? So we play as long as the game is not over. We come back to the play method. Okay, so first is show the board. Okay, so show board. Okay, ask the user to make a move. Okay, so left, right, top, bottom. Okay, we do this, then process the move, whatever the move is, right? And then I do add random 2/4. Okay, right? Now ask the user to make a move. I'll say char move is get user move. So we have character for a move, so I'm going to have four constants: public static final char move left. We use the key A for left. Okay, let me make it uppercase. Okay, left, right, up, down, left, right, up, uh, down. Okay, right is going to be S, up is going to be W, down is going to be S. Right is going to be D, sorry. Okay, WSAD. Okay, left, right, up, down. Okay, right, and then I write this method get user move. Okay, public char get user move. Okay, so just as we showed in the sample run, I choose one of WSAD characters as the input, and based upon that input a user move is made. Okay, right, so I say show all possible moves. Okay, so I say this out. Okay, uh, choose a move. Okay, I say this out. So W/W is going to be up. Okay, similarly we have S, A and D. Okay, S is down, A is left, D is right. Okay, read the move from the user. So to read the move from the user, read input from the user, we need a scanner class object. So I'm going to say private scanner scanner. Okay, and create the scanner object to read from the user. Okay, so scanner equal to new scanner system dot in. Okay, so I have already prompted. I'll say system dot out dot print enter move. Okay, and I say string move input is scanner dot next line. Okay, we read the entire line of input. Now this move is valid if it is one of WSAD ignoring the case. Okay, so if move input, okay, dot equals ignore case lowercase a, or okay, move input equals ignore case a WSAD, right? Okay, if that's the case, I have to return the move as return move input, okay, dot to uppercase dot char at 0. Okay, let me just explain this. A W S D. Okay, that is to say, if the input is lowercase a or just uppercase a, or lowercase w or uppercase w, or lowercase s or uppercase s, or lowercase d or uppercase d, it means my input is valid. Okay, and in that case I convert the move into uppercase and then return the first index because my moves are all uppercase. Okay, WSAD. Okay, all right. Now if the input is invalid, if this condition is false, the control comes here. Okay, so I print sys out invalid input. Okay, all right, I change a line. Okay, I show the board, okay, show board, okay, and I recur. Okay, recur as in I ask the user to enter the move again, so I basically just call this function again. Okay, and this will continue as long as the user does not enter a valid move. Okay, all right, we can check this function here. Okay, I'll say char move is console app dot get user move. Okay, sys out user move is plus move. Okay, I'll go back, clear, clear, compile, run. Okay, so choose a move, I say W, move is W. Okay, choose a move A, move is A. Choose a move D, move is D. Choose a move S, move is S. Choose a move F. Okay, F, G, H, hello. So it will keep asking you for the input as long as the input is invalid. Okay, so Q, R, T, I'll say W, and it stops. Okay, so this function, okay, will always return a valid move. Okay, so I have the move now, I have to process the move now. So I write a method process move, I pass this move. Okay, so I write a method public void process move, it takes a move. Okay, the four possible moves are, okay, move left. Okay, I say case move left, case move right, case move up, case move down. Okay, and you have to break after each. Okay, break, break, and break. All right, now this is one of the critical parts of this code, right? How do you process a move? How do you process when the user chooses to move left or right or up or down? Okay, so let me go back to our explanation, right? Okay, so suppose if this is your board. Okay, so and my board has 2 say 800040 48200044. Okay, so 0 is basically blank locations, but in our 2D array it will be a value 0. Okay, when I swipe this left, that is I choose the left move, all rows are shifted to left. Okay, so this goes to left, this goes to left, this goes to left, and this goes to left. So what happens in this 2 and 2 merge. Okay, first row becomes 4800. Okay, the next row becomes, okay, the next row becomes 4000 because this 4 comes at the first location. Okay, then the third row remains the same. Okay, because there is no movement, there is no merging, and in the final case this 4 and 4 merge, become 8, come to the extreme left, and then the remaining locations are blank. Okay, this is what we have to handle about merging left. Okay, so let me just take the cases 4422. Okay, this on left merge is going to give me these two merge and these two merge, so 8400. 4244, okay, on left will give you these, and these 4 and 2 remain the same, these 4 merge to become 8, and then the last location is 0 blank. Then we have 4822. Okay, on left merge 4 and 8 stay there. Okay, 2 and 2 merge, they become 4 and 0, the last location. Then if we have 8824 on left merge, 8 merge becomes 16, 2 and 4 remain same, last location is 0. Okay, then if we take 4480 on left merge, 4 and 4 become 8, this 8 stays here, and 0 0. Okay, so this 8 and this 8 will not merge, only two consecutive values will merge, right? You have to take note of it. Okay, now how do we code this? Okay, so for us these row is basically an array. Okay, so 4 4 2 2, this is an array, and we have to get this array 8400. Okay, on left merge. How do we do that? We copy all the non-zero values from this array into, say, a temp array. Okay, so all non-zero values are 4422. Okay, and I'm saying non-zero value because there are rows which have zero values like this. Okay, you don't have to worry about this. For example, okay, 2 2 4 0 will have the same merge as 0 2 2 4. Okay, they both on left merge will give you 4 4 0 0. Okay, that's why we copy only the non-zero values. Okay, we copy non-zero values in a temp. Okay, we start from this location I, we go from left to right. If ith and the I plus 1th location is the same, we set the value of I equal to twice the value. So if this was x here, we make it 2x. Okay, so this location becomes 8 and then we have the remaining values. Okay, I is here. So after setting x to x, we copy all the values from the next location onwards. That is, we copy this value here, this value here. Okay, so our array becomes 8 2 2 2. Okay, so a part was if I and I plus 1th location are the same, you set the ith location value if it is x to 2x, because they are same, you have to merge them. B part is from the next location onwards, from I plus 1 onwards, copy the remaining values. So 2 comes here, 2 comes here. In the C part, set the last location to 0. Okay, so C part is set the last location to 0 and you get this. Okay, so after first merge, you get this array. Okay, I is still here. I moves on to the next location, I comes here. So, okay, your array is basically 8 2 2 0. Your I was here, I comes here. You do the same thing. If the value here x is same as the next location value, we make it 2x. Okay, so this becomes 4. Okay, this is the A part. Then starting from the next location, from I is here, right? Starting from next location, we copy value. So 0 comes here. So 8 4 0 0. Okay, and the third part was set the last location to 0, which already it is. So this is the array that we get, that we are looking for. Okay, 3 parts. Okay, and that's what we code. Okay, so let's go back and write a method to left merge. So I'll say static int process left move. Okay, and it takes a row. Okay, because if I move left, okay, all these rows have to merge left, so I do it row by row. Okay, the first thing is copy non-zero values. Okay, int new row, okay, is equals to new int 4. Okay, okay, so for int I equal to 0, I less than 4, I plus plus. Okay, int j equal to 0, I say if row I is not equal to 0, this is a non-zero value, we do new row of j plus plus is row of I. Okay, and we copy all the values, int row and array. Okay, all right, copying all the non-zero values, then merge the values in this new row. Okay, so merging was again I equal to 0, I less than 4, I plus plus. Okay, if the value at this ith location and the next location is the same, that is if I less than 3. Okay, if new row of I equal to new row of I plus 1. Okay, and you can also check if new row of I is not equal to 0. Okay, no point merging two zeros. Okay, so what we do is we set new row of I is equal to 2 into new row of I, right? Then copy the remaining values. Okay, so this was step A that we discussed. This was step B for int j equal to I plus 1, j is less than 3, j plus plus. Okay, we do new row of j, okay, is equal to new row of j plus 1. Okay, and the part C was set the last location of this row to 0. So new row of 3 equal to 3 equal to 0. Okay, I've already declared j, so I'm not going to use and declare j again. Okay, all right, and finally I return the new row. Okay, the row that you get after left merging the values. Okay, and we have to do it for each row. Okay, let us just maybe dry run it for another case. Okay, so we can take 4 2 4 4 I is here. Okay, if value of I is equal to next location, false. Okay, so if this is not the case, if the values at two location is not the same, okay, you move on to the next value of I, you come here. Okay, value of this location equal to this location, no, you come here. Value of this location equal to this location, true. Okay, you set this value to double, so now array becomes 4 2 8 and 4. Okay, then what you do, you copy value starting from here. When you start from here, there is nothing to copy. Okay, so step A and B are done. Then what you do is set the last location to 0, which you do this. So for 4244 you get 4280. Okay, which is this is what we need. Okay, all right, so this is your process left move. Okay, all right, so if you want to test this left move, okay, let me just write a helper array, static void show array. Okay, takes an int arr. Okay, so sys out, I'll say, okay, for int I in arr, sys out I, okay, plus space, okay, and sys out. Okay, so I'll say comment these parts. Okay, I'll say show array, I'll say int arr equal to, the sample test case was 4422 4422. I'll say show array. Okay, I'll say sys out on left, I'll say this, on left move is, I'll say show array process left move on this arr. Okay, and I'll change a line at the end. All right, so let me run this, clear, compile. On left move is 8400. Okay, if you want you can do this, compile. Okay, the other example was 4244. Okay, so 4244. So Java C, 4244 on left gives 4280 the way we want. Okay, 4280, then we have 4822. Okay, 4822. Okay, so Java C, Java. Okay, 4840. Let me make this 0222. Okay, so Java C, Java. So these two become 4. You have 1 2 left, which is this. Okay, and you can check that this is always going to work correctly. Okay, and I'll tell you in a moment why I focus so much on the left move, because using the left move we are going to make all other moves. Okay, so a left move works. Okay, so in order to code left move, what we do is, okay, for each row I say for int I equal to 0 for I plus plus. Okay, I get the new row. Okay, I'll say int new row is process left move, and you have to send the ith row. You can send this as board of I is the ith row. Then copy values from the new row to the row. Okay, for int j equal to 0 is then 4 j plus plus. Okay, we say, okay, board of I comma j is new row of j. Okay, this is your left move on the entire board, because we process left move for each of the row. Okay, for each row we are getting the new row after processing, and then we replace this original row by new row. Okay, you actually cannot change the array location, you can definitely change the values. That's what we are doing. Okay, let's move on to move right. Okay, so if I have 4422, okay, move right. Okay, so the same thing happens, but 00 and 84 instead of 8400. Okay, so 4244 on right move will give us 8 2, 4 and 0. Okay, again 8, 8, 2, 4 on right move will give us 4, 2, 16 and 0. Okay, so you can think of right move as left move on reverse of array. That is, if you want right move on this, reverse this. So when you reverse this, this becomes 2, 2, 4, 4. You do left move on this, it becomes 4, 8, 0, 0, and then you reverse it back, it becomes 8, 4, 0, 0, 8, 4. Okay, which is what we want. Okay, similarly for this case, if I want right move of this 4, 2, 4, 2, 4, 4, you reverse it, it becomes 4, 4, 2, 4. You do left move on this, it becomes 8, 2, 4, 0, and then you reverse again, it becomes 0, 4, 2, 8, which is what we want. Okay, so right move is basically, okay, reverse row, okay, plus left move on the row plus reverse row. Okay, and that's how we code our right move. Okay, so I'm going to write a method public void process right move. This is left move. I say, oh, I have to make it public, not static. Okay, so that's why I was able to call this method directly. Okay, so process left move, and then I write similarly process right move. Okay, so copy all the non-zero values. Okay, we get the new row, so I do the same thing. Okay, copy the non-zero values. Okay, then the steps that I took, reverse the row. Okay, so I'll say int reverse row is reverse. Oh, we have to write a method to reverse the row. I'll say public int reverse array. I'll say int arr. Okay, so int reverse arr equal to new int arr dot length, the same length. Okay, I iterate the original array from the last index to the first index. Okay, or first to the last, take either ways. Reverse array of I is equal to arr of I arr dot length minus I minus 1, I minus 1. Okay, return reverse array. Okay, so this method will take an array and return the reverse of the array, and it has to be a return type int arr. I'll say reverse array new row. Okay, you can use the new row itself, we don't need to add this. Okay, you can simply say this, reverse the row. Okay, process left move, so I say new row is process left move new row, then reverse the row, so return reverse array new row. Okay, so this is my right move. Okay, let me see if we can have, okay, process right move, so I say dot process right move. Okay, on right move is, so compile array index out of bounds exception for length 4, I minus minus, sorry. Okay, silly mistake, apologies. Okay, on right move is 0 to 4, which is correct. Okay, let me make this 0 4 0 4. Okay, so clear, compile, run. On right move is 0 0 0 8. Okay, let me make this 4 4 4, so compile, run. On right move is 0 0 4. Okay, so our left move and right move are working correctly. So similarly for each row, okay, in the case of right move, I say process right move. Okay, and I copy the values back into the row. Getting to up move and down move. Okay, so if I have my board again here, okay, Okay, I say 2408220048204422. Okay, and I have to move up. My move up, okay, is on the column. Okay, so in order to code move up, what I do is I create an array out of these column values. So if I have to move up this column, okay, I create a values out of these column 4422. Okay, I left merge on this, so it becomes 8400, and then I copy back to column. Okay, so it becomes 8400, and I am able to code my up move. Okay, so in order to code up move, what we have to do, we have to copy the column values into a row, do left merge on this, okay, and then copy the values back. Okay, so case move up is for each column, okay, for int j equal to 0 for j plus plus. Okay, create from column values. Okay, int row equal to new int 4. Okay, for int I equal to 0, I is less than 4, I plus plus, row of I, okay, is equal to board of I comma j. Okay, now process left move on this row. Okay, so int new row is process left move on this row. Okay, copy the values back into the column. Okay, so I say same thing. Okay, I say row of board of ij equal to new row of I. Okay, and then move down is going to be my move right from values top to bottom. Okay, so if I have to do move down, okay, so I copy values, these values into one array, okay, of these columns, so it becomes 2408. Okay, now I have to right merge this and copy back. Okay, so if this has to be moved down, I copy this. Okay, I right merge this, so it becomes 0004 and copy back, so 0004. Okay, on down move. Okay, so I do the exact similar thing for each column. Okay, you get a row for this column, you do process right move instead. Okay, and you copy the values back, and this is your move down. So our move is done as well, processing move. Going back, add random to random 4, I'll say int r is random dot next int say 100. Get values from 0 to 100. If r percent 2 equal to 0, okay, if I get an even value, I add random digit 2, else I add random digit 4. Okay, and I guess my play method is done. Yeah. Okay, so let me just go back and compile and see if everything is okay. All right, let me just see if I can run the game correctly. Dot run game play. All right, moment of truth. Okay, let me see if my constructor is okay. Okay, in my play I'm adding random to random 4. Okay, show board, get move, process move. Okay, all right, Jai Bajrangbali. Okay, I do. Okay, down right is working fine, then right, right, up, right, up, left, up, 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 right, up, right, up, right. Let's do down, right, up, right, up, right, up, left, up, right, left, up, up, right, left, up, 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 right, down, up, left, right, up, up, right, up, left, up, right, right, right. Okay, and my game seems to be working fine. Let me just stop this and add the final code, which is to basically check for the winner. Okay, so if game 1, okay, because the game will be over from these three conditions. Okay, game over was here. Okay, if the user won, or this is continues as long as there is a place on the board, or user cannot make a move. So if game 1, okay, says out, okay, you won. Okay, else you lost. You lost. Okay, all right. Let me see how far and how much can I play this game. Okay, this might take a while. So right, up, right, up. Okay, so I sometimes I'm giving invalid input, so it is able to understand. Okay, that's why we coded this. Okay, I'm already at 128, not bad. Mm-hmm. Not playing very smart now. Again, not playing very smartly. Okay, I guess I lost. Okay, because after a tile is here, I don't see any consecutive moves possible. So I lost. So you can see the game is working just fine. And this was the code to play a regular 2048 game on simple 2048 game on Java command line console. Okay. So in the next videos, we'll try to make it very object oriented. Okay, we'll try to add more classes, try to make it more organized, and then we try to put it in a GUI so we can use the arrow keys instead of WSAD. We can also use WSAD. We'll try to incorporate the arrow keys so that we can see the boxes and the tiles moving around. Okay, so this was the solution to this problem, and I hope this was helpful. You like this video. Okay, so this video is fairly long and this is not a very easy code. Okay, there are certain things going around, so you'll have to take your time to understand this code. Okay, so let me know in the comments if you have any doubts or if there's a part you don't understand. Okay, you can always let me know in the comments if there's a question you want me to solve or if there's a concept you want to discuss. Okay, so let me know your thoughts about this video. Please like my video, please subscribe to my channel, and thank you for watching.